In this video, we're going to summarise the pH calculations that you might need to do for buffers when either OH- or H+ have been added. So you must get clear in your head, there's lots of different sets of calculations. So with buffers, you might be asked to calculate the pH of a buffer when it's originally made, and that's a separate video that I've already done on paper. This is for when you have a buffer already and then further OH- or H+ are added to that pre-made buffer. So we've got two different sets of calculations we might need to do here. There'll be one way of doing it if you add OH- and one for if you add H+ to your buffer, but they're very similar. In both cases, what you are essentially trying to work out is the HA concentration and the A- concentration. And that's because if we look at the red on the screen here, we'll likely be given Ka, so it's the HA concentration and A- concentration that we need to get H+, which we can then just minus log to get pH. So for both of these calculations, the point is we're trying to get the concentrations of HA and A- after the addition of this extra OH- or H+. So we're going to start off by looking at what happens when we add OH-. So the key thing is when we add each of these things, what do they react with? So if we look at what happens when we add hydroxide, that reacts with HA in the buffer. What that means is that HA is used up. Now if we look at the equation for the reaction of hydroxide with the HA, it also makes A-. So when you add hydroxide to your buffer, you use up some of your HA and you make some extra A-. So if we look at what that means in terms of a calculation, the steps we need to take. First of all, if you don't already know them, you need to work out the original moles of HA and A- in your buffer before this extra hydroxide is added. So that's your original moles. You then need to work out how much hydroxide you've added. So how many moles of hydroxide have you added? So these are just going to be moles times moles equals concentration times volume calculations. Just don't forget to get your volume in decimeters. So you now know your original moles of HA and A-, and you know how many moles of hydroxide that you've added. We've then said that we know that hydroxide that you are adding reacts with HA and makes A-. So if we first of all look at the A-, we know the original moles, but we also know we're making more. So to work out the new moles of A- after this addition of hydroxide, we take our original moles and we add the moles of hydroxide that we added. So you take your original moles of A- that you worked out in step 1, and you add the moles of hydroxide that you worked out in step 2, and that will tell you the moles of A- that you've got after this addition. You then need to convert that to a concentration. So you just divide your new A- by the total volume. Just watch out for that total volume. Make sure you take into account the volumes of everything that's been added together here. So that includes the volume of any hydroxide that was added. So you now know your new A- concentration. You need to do the same for HA. So to get the new HA, you need to do the original moles of HA that you worked out in step 1 and minus the moles of OH- that you added in step 2, because as we said, that hydroxide is using up HA. And then again, you need to convert that to a concentration. So you're going to divide by the total volume to get the HA concentration. So essentially what you've done is original moles of HA and A- and then moles of hydroxide, and you've taken the hydroxide moles away from the HA and added it to the A- to get you new for each, your new A- and your new HA moles, and then got them into concentrations. And you can then plug into this equation to get H+, and then just minus log to get the pH. So that's what you do if you add hydroxide. Looking at adding H plus then, it's a similar process, but again we need to consider what does that H plus react with. So the H plus that you add to your buffer will react with some of the A minus in your buffer, and that will make some extra HA. So this time you are using up A minus and making HA. So if we go through our steps, step 1 and 2 are the same. Work out your original moles of HA and A minus. And then step 2 is work out the moles of H plus this time that have been added. Then we need to work out our moles of A minus. So we need to use our original moles from step 1, and this time we take away the moles of H plus that we worked out in step 2, because as we've said, we are using up A minus because that H plus reacts with it. We then divide that by the total volume to get the new A minus concentration. Again, being very aware that that total volume is the volumes of everything that have been added into this buffer. For the HA, we've got our original moles from step 1. This time we are making HA, so we add the moles of H plus that we worked out in step 2. So our new moles of HA is the original plus the moles of H plus that we added. We then again divide this by the total volume to get the HA concentration. So again, we've now got A minus and HA concentrations, and we can plug them into this expression to get H plus and minus log it as we did before. So this is just a summary slide. So you can see on the left we've got the process when OH minus is added, and on the right we've got the process when H plus is added. So you can see I've just summarised. So for your OH minus, to get your new moles of A minus, you do original plus the hydroxide added, and your new HA is the original minus the OH minus added. And then for H plus, it's new moles of A minus, it is the original minus the H plus, and the new moles of HA is the original plus the moles of H plus added. After that point, these calculations become the same. Once you've got the new moles of A minus and HA in each case, you divide each by the total volume to get the concentration, and finally plug them in that calculation to get H plus. So you can see what the differences are and how they come together in similarity for these calculations. Now, one key thing to remember is that for each one, there are 2 changes to make. You're always adding to one and taking away from the other. Very common mistake is to just either add to the original or take away from the original for one or the other. You must remember you're always adding or taking away from both A minus and HA. That's a common mistake, is to just do one. So that's your summary, and hopefully that's helped you clear those calculations up in your head.